So some of you have an Apple Watch. Well, the Apple Watch communicates through Bluetooth low energy, and it's an out of band protocol. What you really need to know, uh, of course, is the Apple Watch has the same secure enclave and cryptographic processing technology as the phone. So when an Apple Watch pairs with an iPhone, uh, it uses Bluetooth and Wi-Fi uh, to create a session, and then it switches over to IDS, and the Bluetooth and the Wi-Fi become the backup. Uh, and it uses the same set of encryption keys as the phone, but the keys change every 15 minutes. They maintain forward secrecy so that if you were to break one of the keys during communication, it wouldn't be able to intercept any future messages. So we're going to introduce a couple more components that are necessary to make Apple Pay work. And one of them is a secure element. A secure element is another processor, and it's different from the secure enclave. And we've also got the NFC, or near field communication chip, which handles the radio frequency associated with Apple Pay. So when your phone is near a payment terminal, it can automatically detect it through that chip. When you add a new credit card to your phone, that credit card goes to the secure element, and the secure element communicates with the credit card issuer through SSL, and they negotiate whether or not your credit card is allowed to be used in Apple Pay. If there's any restrictions on it, the card issuer also provides its logo or its artwork so that your card shows up on the screen. And of course, this communication is encrypted with SSL, and a secret account number for that particular card is stored on the phone, and the account number is encrypted in a way that Apple can't see. And also, the account number is not the same as the credit card or debit card number. When this card gets stored, a secure enclave generates a AR value, or authorization random value, and this value is needed to authorize any transaction with the card. We'll see how that works in just a second. And of course, the Apple Watch has its own secure element, and if you have a card associated with the Apple Watch, then the secure element also stores the account number on the watch. So if we look at how a secure element and the NFC chip communicate, we find that the secure element can only talk directly to the NFC chip. NFC chip talks directly to the system processor, and the system processor talks to the secure enclave. This is a similar process to how the Touch ID sensor works, whereas the Touch ID talks directly to the processor, and the processor talks to the secure enclave. And how do we keep this communication encrypted if we're passing data through a main system processor? When the phone is manufactured, remember, as we said earlier, the secure enclave has a UID that's burned into it, and at the factory there's a hardware security module. So the UID is given to that module, which then creates a key for the secure element. So now the secure enclave and the secure element have a special key that they can use to communicate with each other. and it's generated from the UID. So if you were to take a secure element and put it in another phone, even though it's got all those account numbers, it wouldn't function because it wouldn't be able to communicate with that secure enclave any longer. The keys wouldn't match. So how does Apple Pay authorize a transaction? Well, when you approach a point of sale terminal, the NFC chip detects a terminal, and as we've already discussed, the secure element talks to the secure enclave through the NFC chip. So if you put your fingerprint on the Touch ID, secure enclave will authenticate you, and it will allow the transaction to proceed. Keeping in mind we have the correct AR value that was created when that particular card was set up in the system. So the AR value is provided to a secure element, allowing the transaction to proceed. If the AR value has changed, then the transaction is not permitted.